In this video tutorial, we are going to discuss about the basic principle of electrophoresis. So let's start our discussion with the very first thing, that is, what is electrophoresis? So let's try to focus on the word electrophoresis. So this electrophoresis is consist of two words. Okay, so one is the term electro, another one is phoresis. So electro means energy of electricity, and phoresis is coming from the Greek word phoros, which means to carry across. So what does electrophoresis means? Electrophoresis means here we are using the electric charge as a energy to carry some molecule, right? So it is another separation technique that we are going to use for separation of various kind of charged biomolecule. Remember one thing, charged biomolecule can be separated with the help of electrophoresis, okay, from a sample, mixture of the sample under the influence of a electrical field. Okay, that means with the help of electrical charge we are going to generate a electrical field, and on the basis of that electrical field our molecules will be separated. Okay, so in most of the cases this separation will be on the basis of the molecular weight, and in some cases we also take another physical properties in our consideration. Okay, so this is what we are going to discuss one by one, but today's focus is all about the basic principle of electrophoresis, the principle by which every kind of electrophoresis works. So let's start. So first one is the charged molecules. So suppose that means here we are using the electrical field or to separate or to migrate molecules, right? So here the charged molecule will migrate under the influence of electrical field, right? So the speed of that migration is depend on the charge to mass ratio. Okay, though the speed of any kind of charged molecules in the electrical field is depend on the charge to mass ratio. That is the important thing. So in that slide we have learned about the two things, that the definition of electrophoresis. So electrophoresis is consist of two terms, one is electro, which is energy of electrical field, and phoresis is the word derived from the Greek word phoros, which means to carry across, and the charged molecule is moved on the basis of charge to migration mass ratio. That means speed of the charged molecule is determined by charge to mass ratio. Okay, now let's come to the basic principle. So before going to discuss about this, I think this picture will help us to understand the basic principle well. So as I have told you that there will be a electrical field, so under that electrical field there will be some force working on that particular molecule. Okay, that means here we are separating the particle, and the migration of particle is due to particular some force are working on that particular molecule, which result in the migration of the molecule in the electrical field, and we are going to discuss about those kind of forces. So the first thing is, under the influence of a electrical field on the molecule there will be a charge called Q. Okay, and on the basis of this there will be a electrostatic force working, and according to the law of electrophoresis this electrical force will be F is equal to Q into E. Q is the charge that is on the molecule, and E is the electrical field. Under the influence of each the particle is moving. So this electrostatic force is the main reason of the moving of that particular particle. Okay, now the resulting migration of the molecules through the media under the influence of an electrical field is opposed by frictional force. That means frictional force is working on the opposite direction to oppose the speed of the migration. Okay, so this frictional force is F is equal to V F. So V is the rate of migration of molecule, and F is the frictional coefficient, We have already discussed about the frictional coefficient in our centrifugation principle discussing video. So today here also the frictional coefficient is working, and this frictional coefficient is depend on the size and shape of the migrating molecule and the viscosity of the solution through which our particle is moving. So up to this part we have learned that according to the electrostatic force there will be a charge on the ion Q, and there will be electrical field, and the product of Q and E is the electrical force on the basis of which our molecule is migrating, and on the other hand frictional force is involved in opposing the migration or in retarding the migration, right, and this is Vf. Now the idea is, in constant electrical field all kind of force that are acting on that particular molecule will balances each other. Okay, that means if the electrical field is constant, then okay, all the force that are working on that particular molecule will balances each other. That means here the electrostatic force will be is equal to frictional force. That means Vf is equal to QE. So under that such condition all the particles will move with a constant characteristic velocity. Okay, that means you have to remember, question will be come from here, that what is the equation or in what condition all the molecules that are in the electrophoretic separation will separate on the basis or with a velocity that is their constant characteristic velocity. So you have to write this equation, that is rate of migration of the molecule into the sediment not sedimentation, that is frictional coefficient is equal to Q into E, that is the charge on that particular molecule and the electrical field. So now from that equation we are going to determine the electrophoretic mobility. Now what is electrophoretic mobility? Electrophoretic mobility is simply the migration of the molecule through the medium. That means the migration of the molecule through the medium is expressed with the help of electrophoretic mobility. So what is electrophoretic mobility? We are going to derive the equation for the electrophoretic mobility from this equation. So electrophoretic mobility is the basically a ratio. Okay, it is the ratio of the migration rate of an ion to the electrical field. So it will be Q by F. Yes. So our electrophoretic mobility is usually expressed in the form of mu, and it is Q by F. It is the ratio of the migration rate of an ion to an electrical field. So that is the basic principle on which a particular electrophoresis is work. This equation is very important because math problems from the electrophoretic mobility often come, and you have to know about the charge and the frictional coefficient, okay, for determining the electrophoretic mobility. They will often give you the frictional force working and give you the migration rate of the charged molecule, so that you can easily calculate the small f, okay, and they will also give you the electrical force and the electrical field, and you have to determine the Q, so that you can ultimately derive the equation for the electrophoretic mobility. That is the type of question usually comes from the basic principle of electrophoresis. So that is what I have written here, that according to the law of electrostatistics, an ion with a charge Q, that means Q is the charge that is acting on the ion in an electrical field of strength E, will experience an electrical force that is QE. The resulting migration of the charged molecule through the solution is opposed by a frictional force, that is Vf. V here is the rate of migration of the charged molecule, and F is the frictional coefficient. Now the frictional coefficient I have discussed with you, that depends on the size and shape of the migrating molecule and the viscosity of the medium. In constant electrical field, the force on charged molecule balanced each other. That is, so that in constant electrical field we will have QE is equal to Vf. so that each charged molecule move with a constant characteristic velocity. So this is the condition in which each of the charged molecule will move through the electrical field at a constant electric characteristics velocity. Now the migration of the charged molecule in the electrical field is generally expressed in terms of electrophoretic mobility, which is the ratio of the migration rate of an ion, that means V, to the applied electrical field, V by E. So V by E is equal to Q by F. So that is the thing. Now let's discuss about the effect of pH on mobility. Okay, so if we focus our equation, that is mu is equal to Q by F, okay, that is the equation for electrophoretic mobility, then we can easily observe that our electrophoretic mobility is directly proportional to the magnitude of the charged molecule, right? And now this magnitude of charged molecule, we all know, is depends on the pH of the solvent. It is the function of the pH of the solvent, because as I have already discussed with you that charge of the particular, because often we are separating protein molecules in electrophoresis, so the charge of protein molecule is depends on the pH of the solvent. Now the pH is maintained by use of buffer at different pH. So the kind of charge that we want to set, we can use buffer molecule on the basis of that. Again, as the molecule exists as a amphoteric, we all know that protein are amphoteric in nature, they will carry the charged molecule based on the solvent pH, right? So that is the idea. That means mobility is directly proportional to the magnitude of the charged, okay, and which is in turn a function of the solvent pH. That is why pH play a great role in mobility, and the pH of the solvent can be determined by using the buffer of different pH, and that is how we can set our pH according to our need. Because most of the molecule is amphoteric, so they will carry the charge based on the solvent pH. So that is the effect of the mobility. Here I have also discussed that the overall net charge is neutral when a particular molecule is in Zwitter ionic state. Zwitter ion means equal amount of positive charge and equal amount of negative charge. You do not think Zwitter ion in such a way that the charge will be zero. No, the charge will be neutral, and hence the mobility is retarded to 0, and at the neutral charge the mobility will be retarded to 0. Why? Because remember, in the electrical field there are two kind electrode, one is negative electrode, another positive electrode, and in negative electrode there will be rain, that is the portion where we are simply adding our solution. Now remember, most of the biomolecules are negatively charged, so that is why the lane where we are going to add our solution is in the direction of negative electrode, so that upon starting of the electrical field the molecule will start migrating towards the positive electrode. Okay, that is our anode. So this migration at normal thing way, when the molecule is in Zwitter ionic condition, the overall net charge will be neutral. Okay, so the mobility is retarded in that case is 0, because if it containing net charge neutral, then it will neither move towards the positive electrode and neither move towards the negative electrode. In case of protein, this kind of situation is called isoelectric point, right? So we have learned effect of pH on mobility, that mobility is directly proportional to the charge, the magnitude of the charge of the solute of the molecule, so which is in turn a function of the solvent pH. So the pH of the solvent can be determined by using buffer of different pH, and as the molecule exists as a amphoteric, they will carry the charge based on the solvent pH. Now we are going to discuss about other factor that affects electrophoresis. First of all, the inherent factor, that means the factor of the molecule. So obviously the magnitude of the charge play important role, charge density, molecular weight, and tertiary and quaternary structure, that means shape, right? That means remember, compact molecule will move faster rather than the extended molecule of the same mass. Okay, because the overall thing is here we are using a media, right, medium, that is in case of DNA separation it is agarose, we are going to discuss in our upcoming videos, and in case of protein it is polyacrylamide gel. So what this kind of gels are? This kind of gels are simply involved in providing a pores, like condition pores in throughout the media, by which small molecule will get the opportunity to move faster rather than the larger molecule. So suppose you have two molecules which is of same molecular weight, but the compact molecule will usually be smaller in size rather than the extended molecule. So the compact molecule will have the opportunity to move faster. That is why the tertiary and quaternary structure also play a important role, along with molecular weight, charge density and magnitude of the charge, important role playing. And external environment is also important, because we have just discussed about the solvent pH is important. So solution pH is important, solution viscosity is important, because viscosity in turn determines the frictional coefficient, and which in turn determines the frictional force which will involved in opposing the migration. Temperature is important, electrical field is important, right? So in case of inherent inherent factors affecting the electrophoresis are magnitude of the charge, our charge density, our molecular weight, our tertiary and quaternary structures are important. External environment, in case of external environment, the solution pH is important, solution viscosity is important, temperature is important, electrical field is important. So these are the important factors. pH in turn play a most important role, because the mobility is directly dependent on the magnitude of the particle, magnitude of the charge of the particle that we are wanting to separate, and this charge is in turn determined by the function by the solvent pH. As they are amphoteric in nature, so they will carry the charges based on the solution pH. So this pH is maintained by using buffer of different pH molecule. And inherent factors are the magnitude of the charge, that is Q, along with the shape of the molecule, tertiary or quaternary, molecular weight will play an important role, and charge density will play an important role. And here the external features, solution pH play an important role, the electrical field will play an important role, solution viscosity will play an important role, and temperature will play an important role. Now gel electrophoresis on the basis of the casting gel tray. So there are of two types. One is horizontal gel tray. This is a type of gel tray known as horizontal, and this horizontal gel electrophoresis is often called as submarine gel electrophoresis. This is important for MCQ purpose, because here the gel is totally submerged into the agarose. Okay, so here the gel is totally submerged in the buffer. Okay, and another kind of casting gel is the vertical gel. Here the buffer the lane for protein, usually vertical gel electrophoresis is performed in case of protein separation. Okay, so here the lane for protein insertion or a protein addition is here, and the migration will be something like that. There will be a buffer tank, and here also will be a buffer tank. This is a vertical gel electrophoresis. And remember one thing, that vertical gel electrophoresis is never a submarine gel electrophoresis, but horizontal gel is a submarine gel electrophoresis. So we have learned today about the basic principle of electrophoresis, that how the electrical force QE and our frictional force working together to migrate the molecule. Then from that equation we have derived our electrophoretic mobility. So electrophoretic mobility is nothing but the term which expresses the migration of the molecule. So then we have discussed about the effect of pH, because electrophoretic mobility is directly proportional to the magnitude of the charged molecule, magnitude of the charge, and which is in turn a function of the solvent pH. The pH is maintained by using buffer of different pH, and as the molecule most of the cases is amphoteric in nature, so the charge that they will carry is depend on the pH of the solvent. So we need to set pH of the solvent very well to separate molecule, and this can be easily performed by using buffers of different pH. Then we have discussed the inherent factor and external factor. Very important inherent factors are magnitude of the charge, molecular weight, shape, that is quaternary or tertiary, and charge density. And here solution pH, solution density, and electrical field, and along with the solution temperature, the solution viscosity, temperature, and electrical field, and solution pH. And then the last thing that we have discussed today, that gel electrophoresis on the basis of gel casting, that is horizontal gel or submarine gel, and another one is vertical gel. So that is all for today. So today we have discussed about the basic principle of electrophoresis. So I hope that you have enjoyed it and understand what I have done today, what I have discussed with you today. So we will come back with our SDS, that is the first gel electrophoresis mentioned in our syllabus. So till then, bye bye.